In the endless cathedral of the cosmos, there are wanderers older than memory, draped in silence, cloaked in frost, carrying with them the faintest whispers of their forgotten birthplaces. These are the comets, icy travelers that haunt the dark gulfs between suns. For millennia, they were seen as omens, messengers of catastrophe or rebirth, strange luminous scars across the night sky. But humanity has since come to know them as frozen archives, relics of creation itself, tiny vaults of chemical memory, locked in fragile bodies of ice and dust. Yet, even with centuries of observation, nothing prepared us for what arrived. For a comet appeared that did not belong to our solar system, nor to the histories of earthbound astronomers. It was not one of our frozen children cast adrift from the Kuiper Belt or the Oort cloud. It came from far away, from a place no telescope could trace. From a silence so deep it may as well have been the void between galaxies. It was named 3I Atlas. This was not simply another icy speck tumbling toward the Sunday. Its very motion betrayed it. A hyperbolic arc, unbound, untamed, untouched by the gravitational leash of our star. It was an exile, racing not toward a return, but toward disappearance here, only for a brief encounter, then gone forever. Like a phantom that glances at us through the veil of time, only to vanish before we can truly understand. Scientists, hardened by data, still felt a tremor of awe, for in that fleeting visitor lay a promise and a question. If such a thing could find us, how many more wanderers drift unseen across interstellar night? What messages do they carry in their fragile bodies, sculpted by alien suns? And most haunting of all, are they mere relics of distant creation, or emissaries of something more profound, more destabilizing than our fragile cosmology has yet imagined? This is the story of 3I Atlas, a comet that forced humanity to gaze again at the abyss between stars and wonder if the universe had just spoken in a language older than time. On a clear night, in the vast dome of the Hawaiian sky, a set of lenses and mirrors trained upon the heavens caught a glimpse of something unusual. It was April 2020 when astronomers, using the Asteroid Terrestrial Impact Last Alert System, known simply as ATLAS, registered a faint point of light moving against the backdrop of the stars. ATLAS had been built to watch for dangerous intruders, asteroids or comets, that might one day collide with Earth. But this time, what it discovered was not a threat in the conventional sense. It was a puzzle, a celestial riddle carved in light. The discovery was at first unremarkable, as countless faint comets are logged each year. Yet within days, as measurements accumulated, the anomaly began to emerge. Its orbit was not the comforting ellipse of a comet bound to the sun, but a hyperbola, an open curve suggesting that this visitor was not returning, but merely passing through. It was a messenger from beyond. The astronomers who first measured its track were struck by its speed. At over 100,000 miles per hour relative to the sun, it moved with a swiftness no ordinary comet of the solar system owner. Its coma, the cloud of gas and dust surrounding its icy nucleus, glowed in ways that puzzled the scientists. Its chemical spectrum suggested materials both familiar and alien, a blend of ingredients shaped in conditions unlike those found around our Sunday. The moment was electric. Astronomers realized they were witnessing not just another comet, but a fragment of another solar system's story, a piece of matter shaped in the gravity and chemistry of a distant star. To study it was to peer into a cosmic archive written millions, perhaps billions, of years ago. The night sky had betrayed its secret. Hidden among its countless lights, a wanderer had slipped through, just long enough for humanity to catch a fleeting glimpse. It was an encounter with something that should not have been there, something that seemed to whisper that our cosmic neighborhood was far less isolated than we had once believed. Atlas, The asteroid terrestrial impact last alert system was never designed to capture such a wonder. Its mandate was born of fear, not curiosity, to give humanity precious days or weeks of warning if a rogue asteroid were ever discovered on a collision course with Earth. Mounted on modest telescopes in Hawaii, its wide-field cameras scanned the night sky systematically, hunting faint motions among the star fields. It was a planetary guard dog, not a philosopher's lens. Yet, in that spring of 2020, Atlas stumbled upon something far stranger than the silent rocks it was trained to track. In the web of moving dots it charted nightly, one betrayed a motion that did not belong. When its trajectory was fit to equations of Newton and Kepler, it would not close into an orbit. The path was open, eternal, the trace of an object unbound. This was not an intruder from our own Oort cloud, shaken loose by some passing tide of gravity. It was a traveler from outside, a drifter from a realm no earthbound observer had ever known. Atlas had unwittingly added a new page to the Atlas of Cosmic Wanderers. Its predecessors had names that echoed through the halls of science. Oumuamua, discovered by Pan, stars in 2017, the first strange visitor from interstellar space. Borisov, revealed by an amateur's telescope in 2019, the first interstellar comet. Now Atlas would join them, as the third discovery in a sequence that suggested the galaxy was not silent, but porous objects from other star systems did not merely exist, they sometimes crossed ours. The significance was immediate. To catch such a fragment was to hold in one's hands, however briefly, a shard of another world's story. For every comet within our solar system, no matter how far it wandered, carried the imprint of the sun's early disk, frozen remnants of our own cosmic birth. But here was something sculpted in an entirely different nursery, around another star, under another chemistry, perhaps under another rhythm of time itself. The Atlas survey, built to defend against disaster, had instead uncovered something more profound. In its cold equations, written by mirrors and sensors, lay the first whispers of a truth. The universe was not a static backdrop, but a living sea, and from time to time, the tide washed objects across the shores of our Sunday, and each one carried with it the possibility of rewriting what we thought we knew of comets, planets, and the fragile architecture of worlds. There is a quiet law in the heavens, a law humanity first grasped through the work of Johannes Kepler and Isaac Newton. Every object bound to the sun must obey the closed geometry of the ellipse. Comets, like planets, return along these paths, sometimes after years, sometimes after tens of thousands of years. They are prisoners of our star's gravity, chained in orbits that always lead them back, no matter how far they wander. But 3I Atlas was different. Its path was not an ellipse, not even a stretched, eccentric one like that of Halley's Comet. Instead, it was drawn on the chart of the solar system as a hyperbola, a curve that does not close, a trajectory that begins in infinity and ends in infinity. This simple geometry carried with it a profound truth. 3. I Atlas was not one of ours. It had not been born in the sun's protoplanetary disk. It would never return. It was passing through, unbound, forever free. The numbers confirmed what intuition already whispered. Its incoming velocity, before it felt the sun's tug, was over 30 kilometers per second relative to the solar system. No comet launched from the Oort cloud could achieve such speed, not even with the violent help of Jupiter's gravity. Only something born elsewhere, in the gravitational forge of a distant star, could drift through space with such momentum. And so, astronomers gave it a new designation, 3I, the third known interstellar object. The I stood not for imagination, though it might as well have, but for interstellar. It joined Oumuamua and Borisov in the small but expanding catalogue of visitors from beyond. To call it unbound by the sun was to recognize a poetic truth. Every comet we had ever studied was part of our family, a frozen archive of our solar story. But 3I Atlas was a stranger. It carried the fingerprint of another birthplace, another star's furnace, another orbiting world's lost companion. And as it rushed through the solar system, it left no promise of return. For astronomers, this was both exhilarating and bittersweet. They had only one chance to watch it, one window of weeks before it would fade into the darkness again. To study it was to embrace impermanence, a fleeting moment of clarity in the great silence of space. And in that brief passage, the very rules of belonging were rewritten. Our sun, for all its gravity, could not hold it. This comet was not of our home, it was of the galaxy itself. Before 3I Atlas tore across our vision, the world had already been shaken by another mystery. In late 2017, the first interstellar object ever confirmed passed silently through our skies. It was christened Oumuamua Hawaiian, for a messenger sent from afar, arriving first. Unlike anything seen before, Oumuamua was long, tumbling, and oddly bright. It showed no coma, no icy tail to betray sublimating gas. Some scientists argued it was a fragment of rock or metal. Others whispered more radical ideas, suggesting even the possibility of an artificial sail drifting between the stars. The shock of Oumuamua was still echoing when, in 2019, 2I Borisov appeared a very different messenger. Unlike Oumuamua, Borisov was unambiguously a comet, with a glowing coma and a long tail, behaving in many respects like our own icy wanderers. Yet it, too, travelled on a hyperbolic arc, racing through from another star system. Together, these two visitors shattered a centuries-old assumption that interstellar objects were too rare to ever be detected in our brief human lifetimes. Then came 3I Atlas, carrying the story further still. Where Oumuamua baffled by appearing cometless, and Borisov intrigued by behaving almost too much like a normal comet, Atlas arrived bearing contradictions of its own. It glowed brightly, its coma shimmering with activity, but its dust patterns did not match the familiar models of cometary sublimation. Its chemistry carried strange fingerprints, spectral lines that hinted at ingredients forged under alien suns. It seemed at once familiar and foreign, recognizable as a comet, but laced with strangeness that resisted easy classification. To astronomers, this progression felt like a rising scale of cosmic riddles. First came the silent rock with no tail, then the exuberant comet with a perfect one, and now a hybrid that seemed to walk between categories. Each arrival deepened the puzzle, as though the universe were delivering lessons in installments. What was once thought to be a statistical impossibility, the chance of observing even one interstellar visitor, was now becoming a rhythm, a cadence. 3 Atlas thus became not just another data point, but a continuation of a story. It carried the weight of Oumuamua's enigma and Borisov's revelations, and it promised that the cosmos was more generous in its gifts than we had dared to dream. The sky, once seen as a stage of predictable orbits, had revealed itself as a crossroads where the lost children of other stars sometimes pass, reminding us that our solar system is not an island, but one strand in a larger cosmic web. Velocity is a language of its own in the cosmos. Most comets, born in the distant vaults of the Oort cloud, fall sunward with speeds governed by gravity's patient hand. They arrive swift, but never beyond the limits set by their tether to the sunday. Even the most eccentric comet, flung inward by a passing star's disturbance, moves within a predictable range. But 3I Atlas defied those limits. As astronomers calculated its inbound speed, The numbers told a story that no local comet could write. Before it even brushed the sun's influence, its velocity stood near 30 kilometers per second, relative to the solar system's center. That figure may seem modest in human terms, but in cosmic mechanics, it was staggering. It was too fast for any comet born of our sun's gravity to achieve. No nudge from Jupiter, no catapult from Saturn, no ancient planetary scattering could explain it. Its path was not only swift, but resolute. This was the hallmark of an object forged elsewhere, one that had carried its momentum across light years, brushing against unseen stars, weaving through the tidal arms of the galaxy, until fate brought it here. And when the sun's pull tried to bend it, tried to drag it into a curve, the comet resisted. Its hyperbolic arc only tightened slightly, but never closed. Its speed was its freedom. For astronomers, speed became a message. This was not the rush of an object bound to return, it was the sprint of a fugitive. It reminded them of Oumuamua's peculiar dash and of Borisov's quick passage. Yet Atlas seemed to combine those precedents into a sharper, more haunting lesson. Interstellar wanderers are not rare flukes, but regular emissaries. The speed was strange because it was unanswerable. Why here? Why now? Out of all the billions of comets adrift between the stars, why did this one find Earth's watchful eyes? Some wondered if we had underestimated the galaxy's debris fields. Others whispered of hidden dynamics in the crowded birthplaces of stars. But all agreed on one thing: speed was not merely motion. In Atlas, speed became the very mark of strangeness, the signature of a life begun beyond the Sunday. When news of 3I Atlas spread, astronomers expected its appearance to follow the familiar script of comets: the slow heating of the sun awakening frozen gases, the release of carbon dioxide and water vapor, the gentle rise of a coma, and a luminous tail unfurling behind. Yet what they saw did not fit so neatly into those models. The coma of 3I Atlas was alive, but in ways that unsettled expectations. Its outgassing was irregular, not the smooth sublimation of a nucleus carved by billions of years in our solar freezer. Jets flared unpredictably, spilling material into space in bursts, as if something inside was fracturing under stresses unseen. Its tail, instead of arching in the familiar curve of solar wind dynamics, seemed to carry shifts and asymmetries that resisted quick explanation. This strangeness puzzled even seasoned cometary scientists, for interstellar objects were expected to behave conservatively, to carry only the simplest forms of ices, long protected in the deep freeze between stars. But 3I Atlas shimmered with complexity. Its spectrum hinted at volatile compounds, sublimating at unexpected distances from the Sun, as though its surface chemistry had been shaped by conditions alien to our own. Carbon monoxide appeared stronger than predicted, while water signatures fluctuated as though locked beneath strange stratifications of ice. The tail itself, that most iconic of cometary signatures, seemed to defy its role as a mere plume of dust. Some measurements showed dust grains aligned in unusual patterns, scattering sunlight differently than in comets of our system. Others revealed ion tails, bending in ways that suggested subtle forces at play, magnetic whispers from the solar wind interacting with material whose properties seemed unfamiliar. To see a comet behave strangely was to feel a quiet dread, as though the cosmos were reminding humanity that even the most ancient categories, comets, planets, stars, were not immutable. 3I Atlas was not just a visitor, it was a challenge, a test of our definitions. If comets are archives of their origins, then this one was a book written in a script we barely understood, its outgassing and tail the first words of a story that stretched beyond our sun, beyond our epoch. perhaps even beyond our imagination. Light is a language, and when 3I Atlas revealed itself to the spectrographs of Earth, it spoke in accents that did not entirely belong to us. Through the prism of observation, astronomers dissected the faint glow of its coma, breaking it into lines of color, each corresponding to an element or molecule evaporating from its icy skin. The tale it told was both familiar and alien. There were the usual suspects: water vapor, the breath of every comet when kissed by the sun, carbon dioxide, carbon monoxide, faint traces of cyanide. These were signatures known from the frozen archives of our own solar system, yet buried among them were strengths and absences that did not align with expectation. The carbon monoxide bands burned more brightly than in most comets of the Kuiper belt. Ratios of certain hydrocarbons seemed skewed, as though this comet's chemistry had been baked in a crucible of conditions unlike those of our sun's nursery. It was as if Atlas carried the memory of another star's infancy, locked within its crystalline lattices of ice. The proportions of its gases suggested a different stellar environment, perhaps richer in heavy elements, perhaps colder in its outer disk, perhaps touched by radiation fields our solar system never knew. To hold such data in hand was to hold a fragment of another solar history, a shard of a planetary system unseen and unnamed. The dust it shed told another story. Microscopic grains glistened in polarized light, scattering in ways that hinted at unusual mineralogy. Some suggested crystalline silicates, not often observed in our comets, perhaps forged closer to its parent star before being cast outward. Others proposed the presence of organic compounds darkened by cosmic radiation in the void between stars. These grains were ghosts of geology, chemical messengers from a place we could only imagine. Astronomers spoke of it as a chemical ghost, a relic of processes no human had witnessed, drifting across light years to dissolve itself before our instruments. And as each spectrum was logged, the question grew heavier: how many other recipes for planetary systems are out there? If our own cometary bodies carry the signature of the sun's birth, then Atlas carried the flavor of another dawn. To study it was to taste the diversity of the galaxy itself, distilled into a single fragile traveler, doomed to vanish, but leaving behind a haunting whisper of its alien chemistry. As telescopes around the world streamed data back to Earth, a new kind of silence grew among the astronomers. It was not the silence of ignorance, but of dilemma. For in 3I Atlas, they saw not a simple story, but a fracture in the confidence of their models. Here was a comet behaving as no comet should, glowing with spectra that defied patterns, leaving a tail that bent in unusual ways, its trajectory whispering of forces unseen. The familiar categories of planetary science seemed suddenly inadequate, and the question arose: how should one even interpret it? The first debates unfolded quickly in papers and conferences. Some insisted that Atlas was simply another interstellar comet, its oddities exaggerated by the limits of observation. After all, only a fleeting window of data was available, and distance blurred every measurement. But others pushed back. They noted the chemical anomalies, the intensity of its carbon monoxide, the peculiar dust scattering, the slight deviations in trajectory. These were not easily dismissed as noise. Was Atlas an ordinary body shaped in extraordinary conditions, or was it pointing toward processes we had not yet considered? Could its chemistry reveal a star system richer in volatiles than ours, or one scarred by cosmic radiation unlike the sun's neighborhood? And what of the deviations in its motion? Were they outgassing effects, or something subtler, hinting at forces still hidden? The dilemma was not merely scientific, but philosophical. Every discovery carries the weight of interpretation, and interpretation is bound by the frameworks we possess. To cling too tightly to the familiar is to risk ignoring the unprecedented. To leap too eagerly into speculation is to mistake noise for revelation. Between these poles, the astronomers argued, each convinced that this icy traveler carried meaning greater than itself. Some called it an artifact of another star's death, a frozen relic expelled when a world-forming disk was shattered. Others wondered if it was less natural, more deliberate, a crafted fragment or technological shard, though such whispers remained confined to the more daring voices at the margins of academia. What united them all was an unease. 3. Atlas was not a comforting confirmation of what we knew. It was a challenge, daring humanity to admit how fragile its certainties were. And as the comet drifted across the night sky, its pale glow became a symbol of that dilemma. The astronomers' silence beneath the stars, torn between categories, between caution and wonder, between data and imagination. Dust, in the language of astronomy, is not the nuisance it is on Earth. It is the raw fabric of worlds, the grains from which planets coalesce, the residue of stars ground down by time. Comets carry this dust like libraries in miniature, each particle a record of ancient chemistry. When 3I Atlas began to shed its cloak, astronomers watched eagerly, hoping to decode its origins in the patterns of the dust it released. What they found was unsettling. The grains escaping from Atlas did not behave like those of solar system comets. Under the gaze of polarized light, their scattering betrayed odd geometries, shards more jagged, more irregular, as if carved by harsher conditions. The distribution of sizes also deviated. Instead of the familiar mix of fine powder and larger fragments, Atlas seemed to favor coarser particles, heavier grains that clung together even as they streamed into the coma. The dust's spectral fingerprints carried more riddles. In some wavelengths, astronomers detected the subtle shimmer of crystalline silicates, minerals that suggested formation close to a star's heat before being exiled outward. Yet mingled among them were darker, carbon-rich compounds, scorched by cosmic rays in interstellar space. This duality implied a violent history born near warmth, cast out into cold, hardened by radiation, then flung across light years to drift into our sight. To hold these grains, in theory, was to touch an alien geology. They told of chemical processes that had no counterpart here, or at least none observed in our own comets. It was as though Atlas had carried fragments of an impossible workshop, where dust was forged under rules we had not yet written. The anomaly was not trivial. Dust defines comets as much as ice does. It shapes their tails, their comas, their interaction with sunlight. If Atlas bore grains unlike our own, then it suggested that planetary systems elsewhere could produce matter in ways our theories had not predicted. This was not merely an odd comet. It was a clue that our cosmic recipes were incomplete. The phrase circulated in hushed tones among astronomers, grains of the impossible. Each fragment, dissolving into space, seemed to whisper of distant furnaces, of other suns, of cosmic alchemies that had left their fingerprint here, only to vanish as quickly as it appeared. As the weeks of observation unfolded, astronomers turned their calculations not only to the light of 3I Atlas, but to its path across the void. Trajectories are, in theory, the most reliable aspect of celestial mechanics. Newton and Einstein left little room for mystery here. Yet even in this domain of supposed certainty, 3I Atlas left behind a whisper of unease. At first, its hyperbolic arc appeared predictable, the unmistakable geometry of an unbound object. But as precise measurements accumulated, small deviations crept into the data. The comet seemed to shift, as though tugged by subtle, uneven hands. The sun's gravity alone could not account for every quiver. Something else was at play. The simplest explanation was outgassing. Comets are known to adjust their paths when jets of vapor erupt unevenly, like tiny thrusters pushing them into new directions. But the irregularities of Atlas did not always align with the visible activity of its coma. Some deviations occurred when its surface appeared calm, others were larger than the observed outgassing could explain. The comet's motion carried a question mark, a quiet resistance to neat equations. Astronomers compared it to the case of Oumuamua, whose trajectory had also bent in inexplicable ways. In that instance, some proposed exotic explanations: hydrogen ice sublimating invisibly, ultra-thin shapes responding to sunlight, even speculative whispers of artificial origin. For Atlas, the debate revived. Was this merely another instance of uneven sublimation, or was the galaxy hinting at forces not yet catalogued? The gravity question reached deeper than a single comet. If interstellar wanderers consistently defy our models, then perhaps our understanding of small body physics is incomplete. Perhaps the rules forged in the laboratory of the solar system are not universal after all. It is in such deviations that revolutions begin. A fraction of a degree here, a sliver of acceleration there, can unravel whole frameworks of understanding. And so the astronomers watched, rechecked, recalculated, haunted by the possibility that a grain of ice, a fleck of dust from another star, was exposing the limits of centuries-old laws. 3. Atlas, in its silent arc, asked a quiet but dangerous question. Are we sure we understand how gravity and matter truly dance in the wide spaces between stars? The strangeness of 3I Atlas could not be contained within the frame of a single telescope. Its mystery demanded a chorus of instruments, scattered across Earth, each trained on the fleeting traveler before it vanished into darkness forever. From mountaintop observatories to desert installations, from orbiting satellites to backyard astronomers' rigs, the global scientific community turned their eyes toward the same wandering speck of light. In Hawaii, the Pan-STARRS telescope extended the work begun by Atlas, tracking the comet's motion with exquisite precision. In Spain's Canary Islands, the Gran Telescopio Canarias probed its spectrum, teasing out faint whispers of exotic chemistry. In Chile, the European Southern Observatory's instruments dissected the comet's light in the high, dry air of the Atacama Desert, where Earth's atmosphere thins enough to yield clarity unmatched elsewhere. Meanwhile, space-based telescopes like Hubble joined the vigil, staring without the veil of air, measuring brightness fluctuations invisible from the ground. What emerged was a collective portrait, as though dozens of hands were sketching the same phantom from different angles. One observatory reported bursts of unexpected dust jets, another measured spectral lines that hinted at molecules unseen before, another traced deviations in trajectory. Each detail added to a mosaic, a pattern that grew stranger the more complete it became. Communication between scientists became urgent, electric. Data raced across oceans in near real time, each observatory feeding the global effort. Amateur astronomers contributed as well, their smaller instruments filling in gaps when professional facilities were clouded or redirected. For a brief span of weeks, the world seemed united in the act of watching one fragile messenger from beyond. This global collaboration was not merely practical, it was philosophical. It underscored the rarity of the moment. A chance alignment of orbits had brought an interstellar traveler into our reach, and humanity responded as a single species, straining every lens toward it. Each photon captured was a piece of history that would never repeat, for Atlas would never return. The Earth itself seemed to lean toward the comet, turning its telescopes like eyes toward the visitor, desperate to memorize its features before the dark reclaimed it. And in that collective gaze was an unspoken truth. The universe had given us a gift, but only briefly, and we would spend decades interpreting what those hurried nights had revealed. Every comet is a time capsule, But an interstellar comet carries something far older than our own beginnings. When 3I Atlas revealed its spectrum and dust, astronomers realized they were not simply studying ice and rock, they were touching the story of another solar system's birth. For our own sun, the record is clear. The solar system was born from a nebula, collapsing under gravity, igniting nuclear fire in its center. Around it, a disk of gas and dust swirled, clumping into planets, comets, asteroids, each carrying in its chemistry the memory of its environment. Our comets preserve the cold chemistry of the outer regions, molecules frozen since the dawn of time. Atlas carried this same principle, but with a difference. Its recipe was not our sun's. Its volatiles, its dust, its strange ratios of gases pointed to a nursery where the rules were different. Perhaps the star that birthed it was heavier, flooding its disk with stronger radiation. Perhaps it was a red dwarf, colder, shaping ices in different balances. Perhaps the disk was seeded by the ashes of nearby supernovae, enriching it with heavy elements we rarely see in our own small bodies. To hold this comet in theory was to glimpse the diversity of the galaxy's worlds. It told us that planetary systems are not uniform, they are experiments, each sculpting its comets and planets according to the unique rhythms of their star's birth. If our comets are children of the sun, Atlas was a child of a stranger, carrying the genetic code of another family. This was more than curiosity. It meant that by catching interstellar comets, we could begin to sample the chemistry of other planetary systems without ever leaving our own. Each one is a shard of geology and chemistry from a star we may never see, a messenger that lets us taste the universe's variety. And in Atlas, we learned that creation is not singular. The universe does not write one story of planets and comets, it writes billions. This small, icy wanderer, glowing faintly as it rushed past, carried within it a universe of difference, proof that our sun's way is only one way among many. Every orbit is a memory. The comets of our solar system trace ellipses that return them, again and again, to the sun's heat, and each pass imprints new scars, a surface darkened, a layer stripped, a jet opened. Over time, their bodies record the rhythm of their journeys, the cycle of freezing and thawing that marks them as children of the Sunday. But 380LAS bore no such recurring memory. Its orbit was not a loop, but a line, unspooling from infinity into the solar system and then returning to infinity again. This was a comet without return, and so its memory was older, deeper, and more cryptic. It carried not the recollections of repeated encounters with our sun, but the single enduring mark of its birthplace and the long exile through interstellar night. In its chemistry, its dust, its unpredictable jets, one could read the story of that birthplace. Its abundance of carbon monoxide suggested it had formed far from its original star, in a zone where temperatures never rose high enough for such volatile ices to evaporate. The crystalline silicates hinted at matter once forged close to heat, then scattered outward in a violent rearrangement. Atlas was the child of an ancient scattering, ejected from its home system before it could be locked into orbit. It had wandered ever since, carrying its star's forgotten fingerprint through the galaxy. Unlike our comets, which remember the sun's pull like a recurring dream, Atlas remembered only its expulsion. It had drifted for millions, perhaps billions, of years through the emptiness between stars. Along the way, cosmic rays had carved into its surface, darkening it, toughening it, leaving it scarred with radiation that told of time itself. And so, when it arrived, it offered not the memory of an orbit, but the memory of exile. It was not a body that repeated itself across ages, but one that had carried the same straight trajectory for eons. To study Atlas was to study the persistence of memory across interstellar space, a fossil of dynamics we could never directly witness. This was its quiet revelation. Comets are not only the archives of solar systems, they are also the wandering memory of the galaxy, each carrying the record of forces that shaped them and the silence of the journeys that followed. 3 Atlas was, in essence, an ancient diary written in ice and dust, telling us not of cycles, but of singular exile, drifting without end across the stars. With every discovery came not only wonder, but unease. For comets, no matter their origin, have always carried a dual symbolism in the human mind. Messengers of creation, but also harbingers of destruction. When astronomers studied 3I Atlas, they did so with reverence, but also with the quiet recognition of danger. If such interstellar objects pass through often enough to be found 3 times within a few short years, how many others slip by unseen? And what if one, instead of gliding harmlessly past, set its trajectory directly toward Earth? The kinetic energy of such a body would be unimaginable. Even a fragment of a kilometer-wide comet, striking at interstellar velocity, would unleash devastation beyond comprehension. The Earth has known great impacts before the scar of Chicxulub still speaks of worlds ended. But an interstellar impactor would carry far more speed, far more energy, than any comet of local origin. A rare chance encounter could, in theory, erase civilizations, even rewrite the biosphere. Yet there is another possibility, one that casts comets not as destroyers but as givers, for within their frozen cargo may lie the molecules of life itself. On Earth, theories of panspermia suggest that life's building blocks or even microbial life could have been seeded by comets long ago. If so, then 3I Atlas was more than a threat. It was a carrier, a cosmic vessel bearing chemistry from another sun, perhaps even another form of biology waiting in slumber within its grains. The paradox was profound. Was Atlas a symbol of danger, a reminder that interstellar debris may one day shatter our fragile world? Or was it a symbol of connection, a courier that suggested life may not be confined to the narrow cradle of Earth, but spread across the galaxy on icy messengers like this one? To watch it was to feel that tension. Humanity stood beneath its faint glow, wondering whether it was gazing at a ghost of destruction or at the seed of arrival. And in that moment, the comet became more than a scientific puzzle. It became a mirror, reflecting our deepest anxieties and our most hopeful dreams of survival, of connection, of life beyond the fragile boundaries of our own solar system. Even in the smallest of bodies, the great laws of physics whisper. 3I Atlas was no giant planet, no black hole bending starlight, yet its passage was written against the curved fabric of space-time itself. Einstein's general theory of relativity tells us that nothing, not even a comet born of another sun, can travel without leaving faint traces in that geometry. As it plunged toward the sun's domain, astronomers calculated not only its Newtonian arc, but also the subtle relativistic corrections that governed its path. These corrections were tiny, imperceptible to the eye, yet they revealed the quiet interplay of matter and curvature. Even a frozen fragment the size of a mountain carried mass enough to be woven into spacetime's tapestry. Its hyperbolic orbit, shaped by the sun's pull, bent through that invisible curvature like a brushstroke on a vast, unseen canvas. For some, these calculations were simply the precision of orbital mechanics, but others saw a deeper poetry. A visitor from another star, formed in a nursery light years away, was now tracing its destiny through equations Einstein had written a century ago. It was as though the comet itself were affirming those ideas, whispering that the geometry of space-time belongs to all the cosmos, not only to Earth's small neighborhood. And yet, in the subtle deviations of its motion, the question lingered. Were all of its anomalies explained by outgassing and relativity? Or did its path hint at something stranger, a tug unaccounted for, a hint that space-time itself might still hold secrets at the margins of our measurements? To think of relativity in the presence of a comet was to realize that no object is too humble to be touched by the great laws of the universe. Even a fragment of ice drifting between stars obeys the same principles as galaxies and quasars. In Atlas, the infinite and the intimate met. Einstein's mathematics guiding the arc of an alien wanderer, reminding us that every trajectory, however small, is a story written in the curves of space-time. Beneath the scale of relativity, deeper still than the curves of space-time, lies another realm, a domain of probabilities, uncertainties, and flickering energies. It is the quantum world, and in comets, it exists not as abstraction but as frozen chemistry, grains of matter shaped by laws stranger than gravity. In 3I Atlas, this quantum undercurrent seemed to whisper louder than usual. Consider its dust. Each grain, microscopic in size, is a cathedral of quantum architecture, atoms arranged in lattices, silicates bound in crystalline order, organics tangled in carbon chains. These structures form not merely from classical cooling, but from the probabilities of molecular encounters, the tunneling of particles through barriers, the delicate dance of energy levels. In the cold, near absolute zero environment of interstellar space, quantum mechanics reigns supreme, guiding reactions that classical chemistry would forbid. Astronomers speculated that Atlas's unusual chemistry, its excess of carbon monoxide, its strange dust grains, might be the result of such processes. In the lightless gulfs between stars, cosmic rays and quantum tunneling can coax molecules into existence that would never survive in warmer environments. Hydrogen atoms slip through barriers, reforming bonds in ways that defy classical expectations. Complex organics can assemble slowly, patiently, across millions of years of isolation. What Atlas carried, then, may have been not just alien chemistry, but alien quantum history. Its ices were archives of molecular experiments performed by the universe itself, experiments conducted in silence, in the long darkness between suns. When its coma flared under the sun's heat, it released these molecules into light for the first time in eons, allowing humanity a fleeting glance at reactions born from quantum chance across unimaginable distances. It was a reminder that comets are not merely celestial snowballs, they are laboratories, natural quantum reactors, preserving the improbable outcomes of particle-scale mysteries. In Atlas, the laws of the very small had written a narrative large enough to be seen across telescopes on Earth. And so, beneath the visible spectacle of the comet's glow, there lay an invisible truth. Every shimmer of its dust was a testament to quantum dust, the strange, improbable chemistry of the void, carried across light years to dissolve before our eyes. Beyond chemistry, beyond gravity, beyond even the whisper of relativity, there are forces more elusive, fields that shape the fate of the cosmos itself. Dark energy, that unseen pressure accelerating the universe's expansion, stretching space apart faster with each passing epoch. It is a mystery so vast that it seems unlinked to the fleeting presence of a comet. And yet, in the reflections stirred by 3 Atlas, some scientists dared to wonder, could such tiny wanderers, drifting across the galaxy, act as tracers of those unseen fields? When Atlas's trajectory was mapped, it showed small deviations, faint irregularities that could be explained by outgassing or perhaps by subtler influences. But in those whispers, a thought lingered. What if comets from beyond the sun could serve as test particles for forces we barely comprehend? The galactic medium is not empty. It is a sea of weak magnetic fields, interstellar gas, and perhaps most enigmatic of all, the unseen scaffolding of dark matter and dark energy. A comet traveling across light years becomes, in effect, a probe. Its dust is bombarded by cosmic rays, its surface etched by radiation, its path nudged by every field it passes through. By the time it arrives, it carries the silent record of that journey. Its chemistry bears the scars of interstellar exposure, its motion whispers of interactions beyond gravity. If thousands of such wanderers were mapped, might patterns emerge, patterns hinting at how dark energy shapes the geometry of the galaxy, or how dark matter clumps invisibly between stars? For now, such speculation lies at the edges of science. There is no clear experiment, no telescope that can yet decode such faint imprints. But the idea resonates because comets themselves are paradoxes, small enough to be fragile, yet ancient enough to be archives of the cosmos. Perhaps in their ice lies more than chemistry, perhaps they are messengers of the deepest forces of all. 3 Atlas, racing unbound, seemed to embody that thought. It was not only a shard of another solar system, but a witness to the long tides that move unseen. Its very presence was a reminder. The universe may reveal its greatest mysteries not only through galaxies and supernovae, but through a single frozen traveler drifting quietly, carrying the shadow of dark energy in its wake. The more scientists unraveled the nature of 3I Atlas, the more it began to feel less like an object and more like a thread, one strand of a fabric we cannot see in its entirety. Some even wondered whether this thread might stretch further than our own universe. The multiverse, a concept at once exhilarating and unsettling. It proposes that our cosmos, vast though it seems, may be only one bubble among countless others, each with its own laws, its own particles, its own birth. Most of these universes would remain forever beyond our reach, sealed off by boundaries no telescope can cross. And yet, some theorists suggest that their echoes might bleed into ours, leaving traces in subtle ways in fluctuations of the cosmic microwave background, in unexplained alignments of galaxies, or even in matter that seems displaced, like debris crossing invisible shores. In the quiet speculation that followed 3I Atlas, a daring thought emerged. What if some interstellar objects are not merely wanderers from other stars, but refugees from other universes? Could fragments born in one reality find their way into another, drifting across the boundary like leaves carried from one river into another stream? For Atlas, the idea was tantalizing not because of evidence it had none, but because of its strangeness. Its chemistry did not fit neatly into solar models. Its dust carried contradictions. Its trajectory whispered of forces unexplained. While science demanded restraint, imagination suggested possibility. What if, in rare cases, the cosmos leaks? What if our reality is not sealed, but porous, its edges bleeding matter into the neighboring infinities? Such questions cannot yet be answered. They belong to the realm of speculation, to the poetry of physics at its horizon. But the comet itself seemed to invite such thoughts. Its fleeting presence, here and gone in a season, reminded us that we live in a universe defined as much by absence as by presence. And in that absence lies the possibility that we are but one of many stories, each sending debris into the others, each leaving traces too small to prove, yet too haunting to ignore. Thus, 3I Atlas became more than a comet. In the imagination of those who studied it, it became a possible trail of the multiverse, a fragile, icy clue that reality itself may be larger, stranger, and more layered than we can yet conceive. Among the most unsettling whispers in modern physics is the concept of the false vacuum, a delicate idea that suggests the universe may not rest in its true ground state. Instead, it may linger in a metastable condition, like a ball perched in a shallow hollow, waiting for the smallest nudge to send it tumbling into a deeper valley. If this is true, Then one day, perhaps tomorrow, perhaps in billions of years, the universe could undergo vacuum decay, a catastrophic shift where the very fabric of reality transforms, rewriting the laws of physics in an unstoppable wave. Into this fragile thought entered the vision of 3 Atlas. For though it was only a comet, an icy fragment of matter, it embodied the question, what happens when matter from one corner of the cosmos encounters another? Could interstellar bodies act as triggers, introducing energies or structures that disturb the delicate balance of our false vacuum? Most physicists argue against such a possibility. The scales are mismatched, the energies too low, yet the spectre remains in imagination. What if the tiniest instability could be awakened by an alien crystal lattice, by a pattern of matter not native to our universe's vacuum state? What if a grain of alien ice carried within it the potential to unlock catastrophe, not because of intent, but because of physics itself? This speculation dwells at the edges of science, in the same territory where fears of particle accelerators once lingered, that smashing protons together might summon new vacua, rewriting existence. We know, rationally, that cosmic rays have performed such experiments for billions of years without ending the cosmos. And yet, the thought persists, because it touches the raw nerve of our vulnerability, the knowledge that even reality itself may not be stable. 3 Atlas became, for some, an embodiment of that dread. A reminder that the universe is not guaranteed, that our laws may be provisional, that our existence may depend on balances too fragile to last. Its icy nucleus, drifting silently through the void, became an unintentional metaphor for that possibility, a shard of elsewhere brushing against our fragile order, whispering that nothing, perhaps not even the vacuum itself, is forever. And in the silence that followed, the comet left us with a chilling question. Do interstellar wanderers carry only memory, or could they, in some unimaginable future, carry the seeds of the universe's end? For all its strangeness, 3 Atlas was more than a curiosity. It was a laboratory, drifting freely through the sky. Unlike the controlled confines of Earth's chambers, or the sterile beams of a particle collider, this laboratory was born in chaos, shaped by alien conditions, preserved across unthinkable distances. Its coma and tail became experiments in progress, unfolding under the gaze of the sun, visible to every instrument humanity could muster. Astrochemists leaned close to its spectrum, searching for molecules that spoke of reactions impossible on Earth. The excess of carbon monoxide hinted at origins in the frozen margins of a distant disk. Complex organics whispered of radiation chemistry that had unfolded over millions of years in interstellar exile. Dust grains shimmered with crystalline structures that betrayed ancient heating and scattering near a foreign star. Each measurement was a data point in an experiment no human hand had designed, but one the cosmos itself had conducted. Even its deviations in trajectory became part of the laboratory. The comet's jets, acting like random thrusters, forced astronomers to refine models of sublimation, thermal stress, and the behavior of ices under alien conditions. The physics of outgassing, tested countless times with our own comets, was rewritten here with a new vocabulary, one written by a star we would never see. The laboratory of Atlas was unique because it was transient. Unlike a machine that runs experiment after experiment, this one offered a single trial. Once the sun's heat tore it apart, once it drifted into darkness, there would be no second chance. Every photon, every spectrum, every trajectory measured was the sum of the experiment's yield. Humanity had to be patient, but also swift, catching every fleeting signal before it faded. And in this way, 3 Atlas became a reminder of science's humility. We do not control the cosmos, we only wait for the universe to offer its gifts. A comet from another star became the perfect laboratory, not because it obeyed our plans, but because it defied them. It revealed the creativity of nature itself, experimenting across scales of time and space we cannot replicate, and delivering the results into our skies like a fleeting revelation. Even as 3I Atlas slipped back into the dark, scientists knew it would not be the last. If 3 interstellar objects had been discovered in just a few years, Oumuamua, Borisov, and now Atlas, then the galaxy must be brimming with such wanderers. And so, the question became urgent. How do we prepare to catch the next one? Not just with telescopes, but with missions capable of reaching it. Already, designs were on paper. Concepts like ESA's Comet Interceptor mission, originally planned to lie in wait for a long-period comet, could in principle be redirected to intercept an interstellar visitor. NASA's researchers sketched out blueprints for rapid-response spacecraft, probes that could launch within months of detection, racing to rendezvous with a new traveler before it vanished forever. Others proposed interstellar interceptors, spacecraft parked in solar orbits, ready to slingshot outward the moment a candidate appeared. Telescopes, too, were sharpening their vision. The Vera C. Rubin Observatory in Chile, with its immense sky mapping survey, promised to detect faint intruders earlier than ever before, giving humanity more time to respond. Orbiting observatories like JWST could dissect spectra with detail impossible from the ground. Each new tool was a silent sentinel, waiting to catch the flicker of another alien fragment before it was gone. And beyond the instruments already built, there was the patient hope of the future. Missions to the outer solar system, where interstellar comets might be detected earlier, could one day be dispatched. Small satellites, cheap and numerous, could swarm around such objects, sampling dust, tasting ices, recording the physics of another solar system at close range. For now, the comet Atlas had escaped our grasp, studied only from afar, dissected by light, but its fleeting visit had galvanized a movement. No longer would interstellar comets be seen as unimaginable flukes. They were targets, laboratories, messengers worth chasing across the void. In the silence that followed Atlas's passing, the watchers prepared. They built instruments, sharpened models, and waited, knowing that at any moment another visitor might light the sky. And when it came, humanity would be ready not just to watch, but to follow. For all the telescopes that turned toward 3I Atlas, there remained an unyielding truth. The cosmos guards its secrets with distance. Even the finest lenses, even the most sensitive spectrographs, strained to pull meaning from the faint smudge of light. The comet was small, dim, and already hurrying away from us. To see it at all was to glimpse a shadow. To know it fully was impossible. Astronomers learned long ago that comets are deceptive. Their comas expand, their tails shimmer, disguising the true size and shape of the nucleus within. For Atlas, hidden beneath kilometers of vapor and dust, the nucleus could not be imaged directly. Hubble's mighty eye, free of Earth's atmosphere, could resolve little more than a glowing blur. Estimates of size varied wildly. Some said it was a fragmentary husk, no more than a few hundred meters across. Others argued for a bulkier body kilometers wide. The truth remained veiled. Spectra, too, were limited. Light from a distant comet is faint, easily drowned in noise. Each line of color carried uncertainties, each ratio of gases shadowed by error bars. Was the excess of carbon monoxide real, or a trick of distance? Were the dust grains truly crystalline, or simply behaving as though they were under the scattering of starlight? The data refused to yield absolute answers. Even its path defied clarity. Small deviations in trajectory teased at hidden forces, but disentangling them from noise was treacherous work. A jet of vapor here, a thermal fracture there, and calculations could swing toward speculation. Atlas was too far, too dim, too brief in its appearance for certainty. And so, the comet reminded humanity of its limits. For all our telescopes, for all our models, there are truths we cannot seize. The universe does not always grant precision. Sometimes it offers only glimpses, fragments, enough to tantalize but not to satisfy. Perhaps that is the point. The limits of vision are also the spark of wonder. To strain against those limits is to acknowledge the immensity of the cosmos and the fragility of our tools. Atlas slipped through our grasp like a dream upon waking, seen, felt, yet never fully captured. And in its retreat, it left behind the reminder that science, like the comet itself, is a pursuit across shadows, always chasing, never fully holding the truth. The story of planetary formation has long rested upon elegant equations and painstaking simulations. Dust gathers, clumps, collides, grows. Disks of gas swirl around newborn stars, giving birth to planets, moons, and comets in predictable rhythms. From this framework, scientists have built models that explain much of our solar system's architecture. But then came Oumuamua, then Borisov, and then, most unsettling of all, 3I, Atlas. Each one chipped away at the neatness of those models. Atlas's chemistry alone unsettled the narrative. Excess carbon monoxide, crystalline silicates mingled with radiation-scorched organics. These combinations implied processes that did not fit the template of our sun's nursery. If planetary disks could form such strange bodies, then the range of possible architectures was far broader than assumed. Perhaps comets are born under countless different recipes, some rich in volatiles, others dominated by heavy minerals, each one an echo of its parent star's particular environment. Its dust, too, bent the models. The jagged grains, the coarser-than-expected distribution, suggested violent ejection events, worlds colliding, planets scattering. Comets flung outward with such energy that they escaped not only their star's gravity, but eventually crossed interstellar gulfs. The traditional vision of a calm, protoplanetary disk, with comets quietly exiled to outer clouds, seemed too gentle for what Atlas implied. Creation, it seemed, might be more chaotic, more violent, more diverse than our theories allowed. Even its trajectory forced a reckoning. If such interstellar wanderers are common enough to appear repeatedly within years, then every star system may be constantly shedding debris. Our galaxy could be threaded with rivers of wandering matter, the flotsam of planetary birth and destruction, endlessly drifting. This vision painted planetary formation not as a closed system, but as a cosmic trade, with material exchanged invisibly across the galaxy. The equations of planetary science were not overturned, but they were unsettled. Each observation of Atlas pressed them to stretch, to flex, to admit exceptions. The universe, it seemed, had more imagination than our simulations. And so, the comet became not just a mystery, but a correction, reminding us that the birth of worlds is not uniform, not tidy, not confined to the rules we have written. It is wider, stranger, and infinitely more varied than we had dared to model. Long before telescopes and spectrographs, humanity had already given comets a place in its imagination. They were seen as portents, fiery scars in the heavens, symbols of upheaval and change. The ancients watched them with dread. In Babylon, their appearance foretold the fall of kings. In China, they were broom stars, sweeping away dynasties. In Europe, they were omens of plague, famine, or war. A comet was never just ice and dust. It was a story, a sign, a messenger. And so, when 3I Atlas blazed briefly across our skies, it carried with it not only the weight of modern astronomy, but also the echoes of that older mythology. Though we now know comets as relics of planetary formation, the emotional response remains. To glimpse such a body, unbound and alien, was to feel the ancient shiver again, the sense that the sky itself was sending a message. This time, however, the message was different. Atlas was not tied to our sun, not born of our solar system. It was not a sign written for us alone, but a fragment from another story entirely. If ancient peoples feared comets as omens from the gods, Atlas was something even stranger, an omen from another star, another world, another beginning. Its fleeting presence bridged science and myth. In its tail, we saw both dust grains scattering light and the age-old image of a celestial torch burning across the sky. In its chemistry, we measured carbon monoxide ratios. In its symbolism, we heard echoes of the idea that life and death, destruction and creation travel together in icy bodies that wander the void. Thus, Atlas reawakened an old connection. Comets have always been mirrors for human imagination, reflecting our fears and hopes back at us. And in this alien visitor, the myth grew deeper. It was no longer a sign of fate limited to kings and empires. It was a reminder that we live within a galaxy alive with wanderers, and that the stories written in the heavens are larger, older, and more mysterious than any myth ever told. From the moment 3I Atlas was confirmed as interstellar, one question lingered like a shadow. What else might it carry? For in its icy vaults, scientists saw not only the frozen breath of a foreign star, but also the tantalizing possibility of biology, or at least the seeds of it. The panspermia hypothesis, long controversial, imagines life not as a phenomenon born solely on Earth, but as a cosmic traveler. Microbial spores, or organic precursors, could, in theory, hitch rides on comets and asteroids, surviving the long exile of space, then awakening when delivered to a fertile planet. Some argue that Earth itself may have been seeded in this way, its oceans flavored by molecules or microbes born far away. Atlas, with its alien chemistry, reignited that debate. The strange abundance of volatiles, the dark organic compounds hinted at in its dust, seemed to echo the kind of ingredients that could form the scaffolding of life. If our comets already carry amino acids and complex organics, then what might an interstellar comet carry shaped by a different star, a different chemistry, perhaps a different evolutionary chance? The idea is both thrilling and unsettling. If comets like Atlas are couriers of life, then the galaxy may be seeded in slow, patient drifts, each star system offering fragments of possibility to the next. Life would not be a local accident, but a galactic inevitability, spreading silently through icy emissaries. On the other hand, such a process could also carry risks. Foreign biology, incompatible with Earth's, arriving unbidden. No telescope can resolve such questions. We cannot know whether Atlas bore life's molecules, nor whether they could have endured the cold and radiation of interstellar travel. But its presence sharpened the imagination, for in that brief season when its coma glowed, humanity glimpsed not just an icy fragment, but a possibility that life, like dust, may not belong to one world alone. And so, in Atlas, science and philosophy intertwined. The comet became not just a relic of planetary birth, but a courier of speculation. Perhaps the seeds of arrival drift ceaselessly through the galaxy, waiting only for planets to catch them. Perhaps Earth itself is not the cradle, but merely one garden among many. When 3 ETLAS crossed our skies, it did more than trouble equations, it troubled our sense of place. For science is not only the accumulation of data, it is a mirror. Every discovery reflects not only the universe, but ourselves. And in Atlas, humanity found a mirror unlike any before, a fragment of a world we will never see, brushing briefly against our own, then vanishing into darkness. It forced the question, what does such a visitor mean? If comets are the archives of their star systems, then Atlas was the testimony of an unknown one. Its dust was alien, its ices foreign, its orbit unrepeatable. To hold it in thought was to realize how fragile our certainty is, how provincial our theories of creation may be. We have always assumed that our sun's way of building planets and comets was typical, that our chemistry was a model for others. Atlas suggested otherwise, that we are not the rule, but one of countless variations. For philosophers, this was a revelation. It spoke of humility, reminding us that our science, though vast, is still parochial, rooted in one star among billions. For poets, it was a metaphor, a stranger wandering through our home, leaving without explanation, reminding us that existence is not confined to what we can measure. For all of us, it was an invitation to widen perspective, to imagine origins and futures beyond the narrow walls of Earth. And so the comet became more than a comet. It became a philosopher's mirror, reflecting back our deepest questions. Are we alone, or are we part of a chorus? Is life bound to one set of conditions, or scattered like seeds across the galaxy? Is the universe stable or fragile, waiting for the smallest tremor to rewrite itself? Atlas did not answer, but in its silence, it forced us to ask again, and in asking, humanity was changed. The comet's greatest gift was not its chemistry or its dust, but the reflection it left behind, a reminder that the cosmos is stranger than we admit, and that our certainty is always only temporary. Though 3I Atlas slipped back into the black, its brief passage left behind an enduring vigilance. Astronomers, planetary scientists, and engineers alike knew that such visitors would come again, and when they did, humanity had to be ready, not with hurried telescope scheduling or last-minute calculations, but with a standing watch, a global vigil. Already, networks of sky surveys scan the heavens each night. Atlas itself, Pan-STARRS, Catalina, and soon the Vera C, Rubin Observatory all serve as sentinels, automated eyes combing through star fields for motions that betray the wanderers. But the lessons of Atlas sharpened their urgency. Detection was no longer just about guarding against asteroids that might strike Earth. It was about catching emissaries from other suns, messengers whose rarity demands swift recognition. This vigilance has taken on a character almost ritualistic. Data streams constantly, algorithms flag anomalies, astronomers on night duty respond within hours. Amateur observers too form part of this quiet watch, their smaller telescopes patching the sky's gaps, their dedication amplifying the global net. A comet like Atlas can appear faint and fleeting, but with a planetary community alert, it need not pass unseen. Space agencies have begun to fold this vigilance into mission planning. Concepts of comet interceptors rest on readiness, on keeping spacecraft poised to launch at short notice. Scientific consortia draft protocols for rapid coordination. Telescopes across continents must share findings instantly, rather than piecemeal. For the next interstellar comet, every second will count, for its stay will be as short as Atlas is measured not in years, but in weeks. The Watcher's vigil is more than scientific practicality. It is symbolic. In it lies humanity's acknowledgement that the universe is alive with motion, that we are not isolated, that fragments of other worlds brush against ours without warning. To keep watch is to confess our smallness, but also to embrace our role as the one species, on one world, that can lift eyes to the night and choose not only to wonder, but to prepare. 3I Atlas passed and was gone, but the vigil it inspired endures, a quiet, patient readiness stretched across the turning Earth, waiting for the next messenger to appear. Silence is not emptiness. The galaxy, vast though it is, holds oceans of matter too faint for eyes, too dispersed for instruments. Yet when three interstellar objects appeared within as many years, scientists were confronted with a paradox. If such wanderers are rare, why have we seen them at all? And if they are common, why is the space between stars still so profoundly silent? The rarity itself is a lesson. Stars shed debris when they are born, flinging comets outward into the dark. Collisions scatter fragments, gravitational encounters cast icy bodies adrift. Over billions of years, the galaxy fills with these orphans. And yet, for every atlas we see, countless others must pass unnoticed, too small, too dim, too fast. The silence between stars is not absolute. It is only a silence born of our blindness. What this suggests is both humbling and haunting. The void is not empty, but populated with invisible travelers, each bearing the memory of its parent star. We do not see them not because they are absent, but because the gulf between stars is so immense that even trillions of comets dissolve into statistical invisibility. Only chance, an alignment of geometry and timing, allows one to blaze briefly into our sight. From this silence comes perspective. If we can catch three within a human span, then the galaxy must teem with them. Each is a lost child of planetary birth, wandering for eons, reminders that the processes of creation are universal, scattering fragments across the Milky Way like seeds in a wind. But because they are so rare to us, each one becomes immeasurably precious, a messenger seen once, never again. Thus, the silence between stars is not void but abundance unseen, a great archive sealed from our perception. And 3I Atlas was the proof, the faint scratch against that silence, reminding us that the galaxy is alive with hidden motion. To live beneath such a sky is to accept that the universe is full but quiet, and that our role is to listen for the rare moments when the silence is broken. And then, at last, it was gone. 3I Atlas, the strange, fragile emissary from another sun, dwindled into the darkness, shrinking to invisibility as it resumed its eternal exile. For weeks, it had been the subject of global attention, a fleeting point of light, pulling the minds of astronomers, philosophers, and dreamers alike into questions of origin, danger, and possibility. And now, silence. Only the memory of its presence remained, carved into data, spectra, and the quiet awe of those who had watched. But in truth, it had never belonged to us. Its orbit was always unbound, its speed too great, its path too straight. It had brushed the sun like a ghost through a doorway, and now it receded into the gulf between stars, where no eye will follow. That was always its fate, not to stay, not to orbit, but to pass. Its departure was not an ending, but an echo. The mystery it brought lingers, woven into our understanding of comets, of planetary birth, of the galaxy's restless exchange of matter. It left us altered, not with certainty, but with questions. Questions about how many other worlds scatter their fragments into the void. Questions about whether those fragments carry destruction or creation, chemistry or biology, silence or message. Questions about what it means for humanity to be part of a galaxy not empty, but filled with invisible wanderers crossing unseen above our heads. The lesson of Atlas was not its data alone, but its reminder. The universe is alive with motion. Interstellar objects pass through not once in an eternity, but again and again, each one a chance for us to listen, to watch, to learn. Some we will miss, some we will see. Perhaps one day, we will even meet one directly, sending our instruments to chase it, to touch it, to hold in hand the memory of another star. Until then, we keep watch. We sharpen our instruments, we widen our surveys, we prepare for the next fleeting emissary. For in their transience lies their truth. They are reminders that the universe is not distant, but near, brushing against us in icy fragments that vanish as quickly as they appear. And as the comet faded, the night sky returned to its usual stillness. Stars burned, planets wheeled, the moon traced its pale arc. But somewhere in the black, beyond vision, Atlas continued on, carrying its story into silence. And humanity, left behind, whispered after it not in grief, but in reverence. For in its passing, it had reminded us of our place, small, temporary, fragile, yet capable of wonder. And so, the tale of Three-Eye Atlas fades, like the comet itself, into memory. What remains is not its image, not its light, not its fleeting curve across the sky, but the hush it left behind, the hush of reflection, of perspective widened. For the universe, in its endless scale, chose for a brief moment to let one of its messengers pass near enough for us to glimpse. And we, fragile creatures on a fragile world, raised our eyes and listened. The comet was small, yet it carried immensities. In its dust lay the chemistry of another dawn, in its orbit the memory of exile, in its strangeness the hint that the cosmos is wider than our theories. It was only ice, only rock, and yet also everything, a vessel of questions, a fragment of time, a mirror for our own uncertainty. Now, as it drifts beyond reach, we are left not with absence, but with presence. Presence of thought, of humility, of wonder. The night sky no longer seems quite so silent. The space between stars no longer seems empty. We know now that wanderers pass through, unseen or unrecognized, carrying the quiet stories of worlds we will never know. And in that knowledge lies a kind of peace. The universe is not indifferent, it is alive with motion, connection, and exchange. To watch a comet is to remember that we, too, are wanderers born of stardust, shaped by gravity, destined to drift through time. So let the image fade. Let the silence return. Somewhere, far away, Atlas continues its journey, and somewhere ahead, another messenger approaches. Until then, we rest beneath the stars, held by their calm light, listening for the next whisper from the darkness. Sweet dreams,